second example we're going to do is going to be referring to finding the coordinates of other points of inflection. So finding the points of inflection basically. And it's of this function f of x equals 8x raised to the fourth power plus 3x cubed minus 6x squared. And so step one to figuring this out is that you have to identify that the inflection refers to when the second derivative is equal to 0. And so to start off, we have to find the second derivative. So first you would find the first derivative by using power rule as we do here, and then you find the second derivative by utilizing power rule again, and you can refer to your yellow booklet to figure that out. And so once you do that, you just set the second derivative equal to 0 as we did down here. It's going to be a quadratic, but the quadratic isn't going to be able to be factorable, so you have to use the quadratic formula. And once you use the quadratic formula, you get that it could either be negative 3 plus the square root of 137 over 32, or negative 3 minus the square root of 137 over 32. And so step 2 is that you substitute those solutions, so those x's that we just found, into the original function, so that f of x equals 8x raised to the fourth power plus 3x cubed minus 6x squared. And so once you do that, you get that the coordinates are 0.272 negative 0.340 and negative 0.460 negative 1.20, and those are your two coordinates, and that's basically how you find the points of inflection. Okay, here's your first IB style question, or your first question, and then pause to figure it out, and then here is your answer. These are like the two coordinates you should get. Your second question, and just remember that range refers to maximum and minimum as well, but it's specific to the y value, so just remember to keep that in mind. Give yourself a second to complete it, and then here is the answer. And then that is a negative 13.01. So that's like the lower boundary, or like the minimum.